Customary law through the United Nations Convention on the Law of the Sea gives states the sovereign right to exploit their resources, but only in accordance with their duty to protect and preserve the marine environment. And this applies both within and outside areas of national jurisdiction. So if deep sea mining were to begin, what considerations have been given to protect and preserve the marine environment against the long-term cumulative impacts? In this presentation, I will give a brief overview of deep sea mining and explain some of the lack of scientific knowledge, especially with regard to water column impacts, in ways that serious harm must be addressed before it starts, and also give a perspective of deep sea mining related to blue economy efforts. And of course, sea mining is totally different from land mining, mainly through its liquid medium and the vast volumes of water through which mining must take place, full of mobile currents that are moving all the time in 3 to 4 dimensions at different depths and speeds. It's also totally impossible to confine the impacts. We have no walls, no fences. And of course, the life there is swimming around all the time and does not really listen to spatial maps. So managing human activities in the ocean requires a totally different approach to land mining. It's not easy to see any adverse effects quickly, and it's certainly difficult to impossible to reverse them. And we must realize that we have one ocean providing humanity's life support system, so we need to protect it. There's a huge amount of theory being written about deep sea mining at the moment, but as a practical example, in Namibia's EEZ, we have the phosphorites occurring in water depths up to 1,000 meters. These are not a new discovery, they've been known for a long time. These are sand-sized small granules in soft shelf and slope sediments. And already 2 licensed blocks have been given out. No mining is allowed as yet. Deep sea mining, the effects on the water column from plumes are multiple and they have not been properly investigated. Everything from noise, mortality, respiration, the visual communications between animals, feeding, buoyancy, toxicity, contamination, effects on fisheries and transport. For this phosphorite proposed mining, the activity would involve bulk dredging of the seafloor, transporting the slurry on shore, and the transfer would occur every 3 days. As I said, this resource is dispersed in the soft sediment. It's not at the surface. It's buried at 1 to 3 meters below the sediment surface. So this would require sucking the bulk sediment onto large hopper dredger vessels, transporting to land, presumably where the processing would take place to separate the granules from the waste. Phosphorites are used for the manufacture of phosphate. We don't know what would be done with the waste, but it's likely to be returned to the sea. So the plume intensity of suspended sediment during the process has really received inadequate attention, and we need to know what would be done. From the activity that were described by the company and the diagrams, they do show that these plumes would be caused both from the excavation and from the dewatering and could have various effects on the sea life. In a general way, there's an excellent article from Drazen et al. And the plumes from any deep sea mining must be considered to affect the water column in the same sort of ways. We see all the various types of life there and how widely these plumes can be dispersed by both the life, by currents, by vertical migrations of the plankton. So to go back to Namibia there, if we go offshore from Namibia more or less in a southwesterly direction now to about 200 meters, it is an upwelling system which is highly productive, as most boundary upwelling systems are. And this is just of interest that while doing some of the work, there were these large pods of dolphins swimming around, and gives testimony to the productivity, the biological productivity of the area where this mining is proposed. It's also really difficult to see or study real-time impacts if dredge removal is going on, and the specific information is needed to assess really how these impacts from the sediment plumes will affect the sea life there. In a cartoon, you can see that the maximum concentration of phosphorites is not at the surface, it's about 1 to 2 meters down, and the intention is to remove this in bulk sediment strip mining type of mining to a depth of at least 5 meters. To date, the investigations have only been done by Grab and Multicore that have listed in the EIA, and really we need to know the contents of a deep set of sediment and what the concentrations of heavy metals, etc., and grain sizes are in the plumes that get distributed. Pelagic waters are really receiving the direct impact from very critical ecosystems such as upwelling ecosystems, and all the effects are listed there. What we're interested in here especially is toxicity and possible decreased fitness and reproduction of the animals that are living there, with the services that are offered by fisheries and the possibility of seafood contamination and biodiversity destruction. To date, most focus on seabed mining impacts has been on the benthic environment, but this pelagic environment is certainly critical for many areas and certainly for the Namibian EEZ. We have strong benthic pelagic coupling in the food webs. We have the carbon and the nutrient cycle strongly linked, and it's a very highly productive upwelling system with fisheries important. We also have strong currents, and we also know that the sediment to be mined is high in heavy metals and radionuclides. This has been known for a long time. It's nothing new, but it hasn't been thoroughly investigated in the impact studies. So the uranium content is high, and particularly high in these anoxic organic rich basin that we have. More recent studies have again shown this high concentration of uranium at the actual station, which is station 17 in the set of investigations that were carried out, and high cadmium. So in practical terms, what does this mean for life in the water column? It means that filter and particle feeders can ingest these smaller suspended sediment particles from the sediment plumes. Remember that most filter feeders are not selective. They just take in whatever particles are around, and to date those have mainly been small nutritious phytoplankton or small zooplankton particles. So we are risking a food web interaction. Just to look at a very, very simplified food web in the Namibian waters, starting at the smallest particles. If we get contamination of the seawater with some of these particles, what's going to happen? What could happen? Well, we could get this first contamination going into unbalanced uptake by the phytoplankton and deciding what sort of phytoplankton are growing there. It could affect the development and survival of the small forms of life. It could build up into unacceptable levels for consumption, and of course unacceptable levels for export with the very strict export rules that they have. Would there be bioaccumulation to the top predators? We don't know. Also remember that any impacts are not just carried around by the water, but we have the active swimmers. One of our important fish stocks, the hake, are found in deeper waters, but the eggs are transported inshore to the inner pelagic waters where they hatch and the young grow. and then migrate back to join the breeding stock. Now the proposed mining is sort of in this route, and we would like to know what these sediment plumes, what effect they will have both on these migrating juveniles as well as on the food that they eat. We know that a large amount of the food is gobies that actually live on the bottom and migrate up and down through the water. It's not only that the area might affect these juveniles, but we also know that these fish move over large distances up and down the coast, so it can be carrying contamination to the larval, the nursery, and the main recruitment areas. In fact, the research shown by a long period of study is that the area targeted by phosphate mining is exactly the chief recruitment area of the hake. These answers are needed before any decisions are made about whether mining should happen or not. This has captured artists' imagination, and this bit of artwork was made in 2013, showing the danger to the hake and the gobies. Going back to Drazen's paper, and to quote, mining impacts on the deep water column must be considered in research plans and technological development, because we must understand the biodiversity and the dynamics of midwater ecosystems and their value to the ecosystem services. So that expanded and focused midwater research efforts and adopting precautionary management now are needed to avoid future harm to deep midwater ecosystems from seabed mining. There's an ongoing heavy debate and concern about deep sea mining. As I mentioned, the UNCLOS obligates all states to protect and preserve all of the marine environment, 100%. Not some smaller fraction. That mining is destructive is known, it's a common statement, and it's not disputable. But globally, deep sea mining is under hot debate. It is spatially unacceptable to trash certain areas in a trade-off with protecting other areas, using the rather outdated argument, it's a big ocean or the impacts are diluted. Scientifically, enough is known for the marine scientific community to be outspoken about the need for more information on the ramifications of impacts from multiple aspects of deep sea mining on ecosystem functioning, and not least of these from the sediment plumes, which will be continuous during the lifetime of mining licenses. Additionally, the high-level panel, which I'm sure you're all aware of, is a panel of certain leaders in the world advising on sustainable ocean economy, and this panel advises that deep sea mining does not really qualify. Taken from the United Nations Environment Programme for financing, turning the tide, how to change the degradation of the ocean industry, and how to finance the sustainable ocean recovery. To quote, the Sustainable Blue Economy Finance Principles define a sustainable blue economy as one that provides social and economic benefits for future and current generations. It restores, protects, and maintains the diverse, productive, and resilient ecosystems, and is based on clean technologies, renewable energy, and circular material flows. Very ambitious, sure, but it's needed. And by this definition, and for the purposes of that particular document, the sustainable blue economy is a goal for the wider blue economy and therefore excludes non-renewable extractive industries such as offshore oil and gas and deep sea mining. Further promotes implementation on the Sustainable Development Goal 14, Life Below Water, and sets out specific guiding principles that support the financial industry to mainstream sustainability of ocean-based sectors. So in conclusion, one ocean. We have one ocean. It's shared by all of us, and we have a common responsibility to conserve it. Both national and international waters are targeted for deep sea mining. Scientific, economic, and social reasons have resulted in hesitancy to rush into this type of mining. And many countries and financing institutions are supporting this strong precautionary approach with moratoria and bans on seabed mining, which are actively exercising the precautionary principle. And to give any doubt to what the precautionary principle says, it tells us that absence of scientific certainty regarding the potential harm is sufficient to prohibit proposed activities and developments until it can be clearly shown that irreversible harm will not take place. For any further reading, and there's a massive amount of literature coming out presently, this is a page for anyone who might be further interested. Thank you.